Okay, good morning, everybody. Hope you guys are doing well this morning. I am going to start today off by talking. Actually, the only thing we're going to do today is we're going to talk about solving nonlinear systems of equation. Now, how that differs from what you did on Friday. On Friday, both of the equations in your system were linear, meaning when you graph them, they gave you a line, and one of three things can happen. You can get no solutions, you could get one solution, or if the lines were the same, you could get infinite number of solutions. So today what I'm going to share with you is how to use that same substitution technique, but to try and solve these nonlinear systems. Now, what makes these systems nonlinear is going to be this equation right here. This is an x squared equation, and hopefully you know that whenever you graph an x squared, you end up with some sort of parabola. It could open up, it could open down, it could be skinny, it could be wider. We're not sure until we graph it, but it's going to be a parabola. That is not a linear equation. Therefore, this is called a nonlinear system. So we're going to solve this algebraically now. So all last week, pretty much, you worked on your packets. You were solving these systems graphically, and I wanted you guys to do that so you had an idea of what you're dealing with. And when you start getting answers now algebraically, hopefully you can visualize why you got one answer, or maybe why did you get two answers, or possibly even four whenever we had a parabola and a circle, for instance. So if we look at this particular problem, the first one is a parabola, and it's going to be a U-shaped. The second one is going to be a line. And so we could end up with two solutions. We could end up with one solution, or maybe we don't have any. So that's always a possibility too. So to get started solving this, it's always easier if you have one of the two equations is a linear equation, then that's the one that you should use to substitute into the other equation. So we're definitely going to use this one to substitute into this second one right here. Now, the second thing that you want to determine is which variable is it easier to substitute stuff in for. If you look in this first equation, there's two different x's, and one of those x's is being squared. So keeping in mind, if I have to substitute something in, I'm going to have to put it in both places, and I'm also going to have to square whatever I put in for the x in the first term there. So that might not be the best place to substitute, but if you look over here for the y is kind of all by itself. There's nothing else happening to the y. That would be a much better variable to substitute in to. So that's what we're going to do. We're going to take this equation that we have right here. We're going to solve it for y, and then we're going to substitute it in to that y right there. So let's get started. So the first thing we're going to do that is we're going to add y to both sides. So you end up with x equals y minus 2. And then we're going to add 2 to both sides. And when we do that, we end up with y equals x plus 2. And so now what you can see is why this equation, actually, I want to show you something real quick. This equation is slope-intercept form. This equation up here was standard form. Okay, so just keep in mind, these are the same line. If you were to graph them, they would be on top of each other. We just changed the form. The first one was in standard form, and then we changed it into slope-intercept form. But now that it's in slope-intercept form, you can see that this equation right here is equal to y. So x plus 2 is equal to y. So what we can do in this other equation, there's a y right there. We can substitute this x plus 2 in for the y variable up there. So that's exactly what I'm going to do. So rather than writing y equals x squared plus x plus 1, I'm going to write x plus 2 equals x squared plus x plus 1. And now from there, this is a quadratic equation. It only has one variable, so we're able to solve this. And your goal to solving these is always to move everything over to one side of the equation and then try to figure out what x is. You may be able to factor. You might have to use the quadratic formula, and maybe you'll get lucky and there's no middle term and you can just solve it by solving for the variable, which I'll show you if we have one like that. So we're going to subtract x, and I end up with 2 equals x squared plus 1. And now I'm going to subtract 2 from both sides, and I get 0 equals x squared minus 1. Okay, so there is my quadratic equation, which I want to solve it. So I'm going to add 2 to both sides. I get 2 equals x squared. And now when I take the square root of it, I get x equals the positive or negative square root of 2. So that right there gave us 2. There's 2 because there's a positive and negative square root of 2. Now the square root of 2 is 1 point something. Doesn't really matter. It's between 1 and 2. But what I want you to understand is those are 2 x values, and we've come up with them. We know that now this parabola over here and this line are going to intersect in 2 different places. And the x coordinates of those intersections are going to be the square root of 2 and the negative square root of 2. So I'm going to, let's see if I have a little bit more room now. So let's see. So we're going to have 2 ordered pairs. We're going to have the square root of 2, comma, and then we need to figure out the y. We have the negative square root of 2, and then we need to figure out the y. We don't know what it is yet. Now, it's really easy to figure out the y. All you have to do is take whatever you get for x and then plug it back in. Now, you can plug it into this equation. You could plug it into this equation, or you could plug it into this equation. Now, remember, these 2 equations are the same. These are the same. But since this last equation right here is already solved for y, and that's what we're trying to get, that's going to be the best equation to use. You would get the same solution no matter which equation you used, but that last one, this bottom one, is much easier, or it's the easiest one to use. So now we're going to take this y equals x plus 2, and we're simply going to substitute in our x values to get our y values. So y equals the square root of 2 plus 2. And then there's nothing else you can do to simplify that. So that's the answer. So when I go to write this, I'm going to need to get myself a little bit more room there. The first ordered pair solution is the square root of 2. And then after we plug that in, we got the square root of 2 plus 2. That's the first solution. Now the second one is going to be similarly done. You're going to take the same equation, y equals x plus 2, and then you're going to substitute in negative square root of 2 plus 2. And again, there's nothing that you can do there as far as simplifying that any further. So that is your answer. And there you go. You can see what I just wrote at the top that I'm going to highlight in red. This is the solution to those 2 systems, or to that one system. Now, don't be intimidated by the fact that we didn't come up with whole numbers. If you remember last week when I discussed why graphing, trying to solve these by graphing is very limited, uh, this is why. There would have been no possible way that you would have been able to come up with that solution by just graphing. So it is important to recognize that we're going to get solutions that aren't perfect integers all the time. There's going to be decimals, there's going to be irrational numbers. All right, moving on to example B. Same idea. We've got a quadratic equation right here, and then we have a linear equation right here, and we're going to substitute one into the other. It's nice on this particular one though, because the linear equation is already solved for y, so we can simply take this negative 4x minus 2 and substitute it right in there for y. So that's what I'm going to do when I write this out. I'm going to write negative 4x minus 2, and then that equals negative 3x squared minus x plus 4. So I simply took this and substituted it right into there. And now our goal is the same as it was before. I'm going to get everything over to one side. So I'm going to add 4x. I'm going to add 4x here. and I get negative 2 equals negative 3x squared plus 3x plus 4. Then I'm going to add 2 right here. I'm going to add 2 right there. And I get 0 equals negative 3x squared plus 3x plus 6. All right, so now we're looking at this quadratic equation, and I need to determine what is the best way to solve it. We have a few different techniques to solve a quadratic equation at our disposal. My recommendation is always try to do some sort of factoring. If it won't factor, then move into the heavier hitting tools like quadratic formula, things like that. So if you look, we can actually take a negative 3 out of this, which is what I'm going to do. And then we're left with x squared minus x minus 2. So remember, whenever we discussed factoring on the review assignment, I said that you should always try to take a GCF out first if possible. This, by being able to take this negative 3 out, it actually made our factoring job much easier because we don't need to use the ABC method anymore. We can just factor it. So it's going to factor like this. We need two numbers that multiply to give me negative 2, but add to be negative 1. And so as you're thinking about that, I'm going to write this like here. So two numbers that multiply to be negative 2, that means one of them has to be a positive and one has to be negative. And of course, to add to be negative 1, the positive number has to be 1 and the negative number needs to be 2. So now it's completely factored. And the last step would be to take these two pieces individually, set them equal to 0. So you can see that. This means x is negative 1. And then we're going to set this one equal to 0. That means x is 2. So I've got two x values. So once again, we know a little bit of information about what the graph of our system would look like now. We have a parabola, which is a U-shaped, and then we have a linear graph, which is a line. In this case, we combined the equations and we solved, and we come up with two x solutions. So those two x solutions tell me that that line is going to intersect that parabola in two places. So again, we're writing ordered pairs. So we know there's going to be an ordered pair negative 1, comma something. And now we also know there's going to be an ordered pair 2, comma something. And to get the y values, you simply take those x values and substitute those in for x. And it doesn't matter which equation you use. I'm going to use the second one because it's easier. So y is equal to negative 4 times negative 1 minus 2. So that gives me 4 minus 2, which is 2. So when I plug in negative 1, I got 2 out of my equation. So the first solution is going to be negative 1, 2. We're going to do the same thing. Y equals negative 4, and then 2 minus 2 like that, which is negative 8 minus 2, which is negative 10. So when I plug in 2, I get negative 10. All right, so there's two solutions to this particular system as well, and those are the two ordered pairs where the parabola and the line cross. In this one, you may have been able to come up with that if you were just trying to solve this by graphing, but definitely you would not have been able to do that for the first one. So, all right, guys, that's what I've got for you today. I have two examples, so please feel free if you have any questions to email me, and I'll talk to you soon.